Okay, so for these, first one up here, metric or standard? Metric. We can tell for two things. It's labeled in 5s here, and if you look up, it goes past 25. So, I mean, this would be 20 and then 0 if this were standard, right? So this is metric. So this is 10, 11, 11.5. What's over here on the thimble? I read it here, so that's the 17. It's real easy to want to look at the pink one that lines up, but you can't do that. Because it's got to be the one that lines up with the 0 axis is where we read the thimble. Now we're back to the vernier scale, and it does line up with the 1. So that means we're putting a 1 after the 17. So this is 11.671 millimeters. So the vernier scale just adds that extra digit at the end. So how about this one? This one's still metric. We're going by 5s. So what's our main scale read? 13.0, right? Then on the thimble, between 8 and 9. We're closer to the 9 probably, but because this is a vernier, we use the smaller one. So that's 13.08. And then it's 5 on the vernier. How many of you got both of those first two right? Good. Down here, these are both what? Standard inches. So it's 0 whole inches. What I'm reading here is tenths. This is 125/50, 150 thousandths. On the thimble, 10. And the vernier is 4. The little pink line makes the vernier kind of easy to read, doesn't it? So 0.1604 inches. Over here, 0.250. Another 10. And 3. So 2603. What do you think? As a group, you guys did really well on that quiz. So this is like the first time in the last 4 years that I haven't had to redo micrometers. So you guys should be proud. I'd say about 4 out of every 5 years I have to do that. So now for the next 4 years, I'll be stuck redoing it again.
How long have you been teaching again?
This is my 17th year. Yeah, I'd say about 4 out of every 5 years I've got to go after the quiz. Scores are low enough that I would go back and redo it. I think out of this group, I think the most anybody got wrong was 2 on the quiz, and it was decimal point places. Okay, so today we've already talked some about volume and surface area. And I gave you some kind of different formulas that I use. In fact, rather than just giving you formulas you can plug numbers into and run out, I gave you some general formulas. So let's look at a problem here. Like say this is 8 inches across and 15 inches in height. For volume, we define volume to be the area of a base times a height or a distance between bases. For surface area, we define surface area to be the area of the bases. I'll put the S in parentheses there. Plus the lateral area, where the lateral area is the perimeter of the base times the height. So for this cylinder here, for volume, my first step is to find the area of the base. Well, the base is the circle, so that area is just going to be pi times 4 squared. Good. Diameter of 8, but for area I need a radius, which will be 4 inches. So that's going to be 50.24 square inches. So when I have the area of the base, my volume is just that area of the base, 50.24 inches squared, times my height of 15 inches. So what, 753.6, something like that? Inches cubed, does that look right? Okay, so there's my volume. For surface area, I have the area of my basis. I've got 50.24 square inches plus 50.24 square inches. I did it twice because there's one on bottom and one on top. Lateral area remember, lateral area can always be made into a rectangle. If I slice this up the side, I can unroll it. And that rectangle has a height that's still my height. That's still 15 inches. It's the length that's the perimeter of the base. So the first step in finding lateral area is always to find the perimeter of the base. Since this has a base that's a circle, it's the circumference of the circle. That circle has a diameter of 8, so it is pi times 8, or 25.12 inches. So from that, I find my lateral area, which is the 25.12 inches times 15 inches of height, which is what, 376.8 inches squared. Does that look right? So that goes up here. So I add those up to get 577.28 square inches is my total surface area. What do you think? Not 500, 400. 477.28. Not so bad? So then, based upon that, if I give you that this is 10 inches wide, 30 inches long, 20 inches tall. Find volume and surface area. I'm going to give you a couple minutes in your notes. Get started on that, see how you do, and then we'll pick it up from there. So what's the first step? Whether I'm finding volume or surface area, the first step is always what? Area of the base. So the base of this is two pieces. One is a rectangle. What's that rectangle's dimensions? 10 inches by 20 inches, right? Because this is 10 inches across here. If that's 10 inches, that gives us a radius of 5 here, so that's 5 off of each end, which makes it 20 across here. So that is 200 square inches. The second piece, and everything, well, there's two other pieces. Well, we have two half circles. I'm just going to put them together to make one full circle with a radius of 5, or a diameter of 10, if you want to think of it that way. So pi times 5 squared is 78.5 square inches. So the area of my base is 278.5 square inches. From that, let's find volume. What do we do? Yeah, 278.5 inches squared times our height of 20 inches is going to give us 5570 inches cubed. Not so bad. You can see that's why I defined volume as the area of a base times a height. There is no standard formula here that would give us that volume. Surface area. Well, I've got 278.5 plus another 278.5 plus I've got to find my lateral area here. So for lateral area, where do I start? Perimeter of the base. The perimeter of the base is going to be 20 inches plus 20 more inches. That's this side and this side, plus circumference of that circle. Make it one big circle again. That circumference, pi times my diameter of 10, is 31.4 inches. Giving us a perimeter of 71.4 inches. Which allows us to find lateral area, 71.4 inch perimeter times 20 inches of height, 1,428 square inches. So if I add those all up, I am going to get what? $1,985 inches squared, is that correct? So you can see, by defining volume and surface area the way I do, it can apply to any shape, no matter how complex it is. What if I look at a cone? Or a pyramid in this case, actually. So if I'm looking at a pyramid, the volume can still be based off of the area of the base and the height. But here, when we're dealing with triangles, we took the area of that rectangle, we divided it by 2 to make the triangle, right? Can I find the volume of the box and divide by 2 to make the pyramid? Well, if I take that pyramid, or that box, and I divide it by 2, I cut it in half, what I get is this shape. Is that a pyramid? No, it's a wedge, isn't it? To make it into a pyramid, I'd have to cut it again across here, like that. Well, what I've cut off there, this piece I cut off isn't half of what was left over because I'm just cutting off the thin part, the pointy part, right? So it's less than half. So what we have here is more than a fourth of what we started with, but less than half of what we started with. Because we did take off a full half of that first cut. We took off that wedge. It was half of the box. Then we took off less than half of what was remaining. Now to get the exact answer would involve calculus. So this is one of the few times where I'm just going to ask you to trust me on the formula. The volume of a pyramid is equal to the area of the base times the height divided by 3. It's 1/3 of the whole volume. Here's the way I remember that. When we do the area for a rectangle, it was length times width and then divided by 2. We divided by 2 here, and a rectangle is 2-dimensional. A pyramid is how many dimensions? 3-dimensional. Volume is 3-dimensional. We're divided by 3. So for this pyramid, the area of our base is 16 inches by 16 inches, or 256 inches squared. So that makes the volume 256 inches squared times a height of 15 inches. But we have to remember to divide by 3, which turns this into 1,280 inches cubed by volume. Make sense? So there's your big change. Your volume is still area of the base times height, but we have to divide by 3 to correct for the pyramid.
How many triangles does it have on each side?
1 triangle on each side there.
3.
So there's 4 total triangles.
4.
Because there's 4 sides to the base. Get confused. Easiest way to draw it is just do this. You draw like a parallelogram, then just put a dot up here, connect that dot down to each of the 4 corners. For surface area, we've got the area of that base, 256 square inches. Notice I'm only writing it down once. Why am I only writing it down once? There's only one of them. Yeah, there is no top on this. So we're going to have to add to that the lateral area. There are going to be some adjustments to our lateral area. We still start out by finding the perimeter of our base. The perimeter of the base here is 16 inches plus 16 inches plus 16 inches plus 16 inches. Or 16 inches times 4, however you want to look at it. Giving us 64 inches is the perimeter of our base. But now as we do the lateral area, there are going to be 2 big differences here. So it's the perimeter of our base times, first of all, when we were doing all other shapes, these lateral surfaces all rolled out to be a rectangle. These are all triangles. So we're doing the area of triangles, we divide by 2. Second, on all the other shapes we were doing, these lateral surfaces went straight up and down. So the length of those surfaces was the same as the height. So the triangles they formed had a height that was just the height of the whole figure. Here, however, the lateral surfaces go at an angle. That's what we call the slant, or the slant height. That slanted surface is longer than just the height of the figure. How can we figure out how long it is? Well, we can do a right triangle like this. What is this height of this right triangle? 15. That's just the height of our figure. What's this base here? 8 inches, just half of our side, assuming that this is a regular pyramid, the point is right over the middle. It's half of the side. So to find that slant, we have that the slant squared is equal to 8 squared plus 15 squared. If you were to walk through that calculation, the slant squared is equal to 64 plus 225. That's equal to 289. Square root it. Get the slant equals 17. So that's the second adjustment to our lateral area formula. It is the perimeter of the base and not times the height. Now it's times the slant divided by 2. So we got the perimeter of the base is 64 inches times the slant is 17 inches. Divided by 2 is 544, right? Inches squared. Does that look right? So we add that to the 256. We get 800 square inches. Is our total surface area. What do you think? Good stuff? Happy and joyous? Well, let's do an example of a cone. You guys talk me through finding the volume. What's my first step in finding the volume? It's always area of the base. How do I find the area of this base? Pi times 5 squared. Yes. Pi times radius squared. So 78.5, this is in inches, so inches squared. Then what? 78.5 inches squared, the area of my base, times my height to 12 inches. Do I multiply that out? Say no. To divide by 3, there we go. Gives me 314 inches cubed. There's my volume. So you got to remember to divide by 3 for the volume. Cones and pyramids, they both go to a point. So for surface area, I have the area of my base, 78.5 square inches. There's only one of them again, so I'm only going to put it in there once. Where do I start out for my lateral area? First step is always the perimeter of the base. This base is a circle, so it's the circumference. Pi times 10, which is 31.4 inches. What's next? Not times 12. Because it's a slope, we've got to find the slant. This is 12. This is 5. So that slant, I always exaggerate my S's so they don't look like 5. That slant squared is equal to 5 squared plus 12 squared. 25 plus 144 is 169. Square root gives you the slant is 13. So the lateral area is the perimeter of the base, 31.4 inches, times that slant height to 13 inches. Remember to divide by 2 because it still forms triangles. Giving us 204.1 square inches. Adding those up, 282.6 square inches of surface area. What do you think? Not horrible? Now pretend I can draw and you can tell what this is supposed to be. What is it? A sphere. A sphere has no base. So there is no area of a base. It has no height. So there is no lateral area. A sphere has only one dimension, and that is its radius. So we have to define everything in terms of just the radius. Now I can derive the formulas for volume and surface area of a sphere, but it involves calculus again, and kind of deep calculus. So for the second time today, I'm going to ask you that once again, this is one of those spots where you're just going to have to trust me that these formulas work. I don't like doing that, and I'm doing it twice in the same day. But so anyway, our volume is 4/3 times pi times the radius cubed. Surface area is equal to 4 times pi times the radius squared. So if I tell you the radius of this is 6 feet, the volume is 4/3 times pi times 6 to the third power. So 4 divided by 3 times 3.14 times 6 to the power of 3. 904.32. That was in feet, so this is going to be in feet cubed for volume. Everybody follow that? The surface area is going to be 4 times pi times 6 squared. If I punch that in the calculator, I get 452.16 feet squared. What do you think? In the packets I gave you, did I give you up to page 194, or do I have to give you another packet yet?